This is a NEET 2016 question basing on capacitors. Let us have a look at the problem. A parallel plate capacitor of area A, plate separation D, capacitance C is filled with 4 dielectric materials having dielectric constants as shown in the figure, right? Now you can have a look at the diagram, right? See the diagram. K1, K2, K3 are sharing area. Entire area is divided as A by 3, A by 3, A by 3, right? So let's talk about that A by 3 part itself. So this part behaves like a capacitor C1, this part behaves like a capacitor C2, and this part behaves like a capacitor C3. What is that C1 is, if I have to write? C1 is K1 epsilon naught, area is A by 3, by the distance is, as it is given, D by 2. So it becomes 2K1 epsilon naught A by 3D, that is C1. Similarly, I can write the values of C2 and C3 also as what? C2 can be written like, because they are all having the same areas and same distances, 2K2 epsilon naught A by 3D. C3 can be written like 2K3 epsilon naught A by 3D, because they are named as K1, K2 and K3. So there are 3 capacitors connected like this, and you can see as C1, C2, C3 shared area, they are parallel to each other. So C1, 2, 3, their combination can be written like C1 plus C2 plus C3. Now look at the C4, this is this part K4. Here only one dielectric is placed throughout the area for the entire area, but the distance is automatically another D by 2. So I can write C4 as K4 epsilon naught entire A, distance is D by 2, that is 2K4 epsilon naught A divided by D. Now let's go to the problem. If a single dielectric material is to be placed to have the same capacitance C in the capacitor, so what he is saying is, in the entire system he want to keep only one dielectric material K throughout the area to the total distance D. In that case, capacity of the capacitor can be written like K epsilon naught A by D. If that is the case, then that dielectric constant K value is how much in terms of this K1, K2, K3 and K4? That's the question that you first need to know. So if I am able to write each of them in terms of this capacitance, it will be easy to calculate. So from here I can write epsilon naught A by D equal to C by K. Everywhere you have epsilon naught A by D. Let's write as C by K, where C is the total capacity of the capacitor when it is placed with a single dielectric material K, and I have to calculate that. So what happens to this C1? You see, 2K1 by 3, instead of epsilon naught A by D, I can write as C by K. Similarly, here also 2K2 by 3 C by K. Here also 2K3 by 3 C by K. Here also, here also I can write 2K4, the place of epsilon naught A by D, C by K. I can write that way. So I have converted all of the data into the format that is needed so that the calculation becomes easy for me. Now let us proceed and solve the problem further. It's very clear that C1, C2, C3 are parallel and their combination is in series with C4. How do I say that? You need to know one important thing, right? As I told you all earlier also, when area between the plates, area of the plates is shared, it is a parallel combination. See this, A by 3, A by 3, A by 3. So the entire area is shared across this. And if you notice, they are all having the same distance d by 2. So that the distance is not shared, only area is shared. So that's a parallel combination. So the combination of C1, 2, 3 is C1 plus C2 plus C3. When distance is shared, it is a series combination. So for this entire parallel combination, distance is shared with the last one. So what we can say, for C1, C2, C3 combination, C4 is in series. So I can write a formula that 1 by C resultant of the entire combination is, as they are in series, we have a formula. You know the formula in 1 by C series equal to 1 by C1 plus 1 by C2. What is C1? Combination of all this. So how much is that? 1 by C1 plus C2 plus C3, because I am considering this entire part as one part that is in series. Then what I can write further? Plus 1 by C4, because this is another part. The upper part and lower part are in series, whereas upper part is a combination of 3 capacitors in parallel. That you need to know. Now let us solve this problem further. In the place of 1 by C resultant, I can call it as 1 by C, where C is this. We have already discussed this, K epsilon naught A by D, equal to 1 by C1 plus C2 plus C3. Let us do what is that C1 plus C2 plus C3 is for the easiness. C1 plus C2 plus C3 is, say this. In all these things, what is common is 2C by 3K, isn't it? 2C by 3K. What else is remaining? Difference is in the numerator, K1 plus K2 plus K3. So in the place of C1 plus C2 plus C3, when you add all these three things, you will get this. So what is that value? 2C by 3K of K1 plus K2 plus K3, that is C1, plus 1 by C4. C4 is this, we already had got this, 2K4 into C by K. So I have to rewrite this. How can I rewrite this? Just write it in reverse, because it's 1 by C4. K by 2 K4 C. That's the answer that I have to calculate. But what I can do now is, C is common in all the denominators, that can be cancelled. Then what is remaining? 1 by 1 equal to this 3K can be taken to the numerator. 3K by 2 of K1 plus K2 plus K3 plus K by 2K4. That's the answer. What I will do now is, I can take K common in both the terms. 2 also common in both the terms in the denominator. Let us take both these parts, this 2 part, into the other side, so it goes to the numerator. This K part to the other side, so that goes to the denominator. So what will be my new equation is, this 2 goes to the numerator, this K comes to the denominator, 2 by K equal to, what is remaining? 3 by K1 plus K2 plus K3 plus 1 by K4. That is the single capacitor, single dielectric material K that has to be placed so that it behaves like a single capacitor, like it has been told here. So I need not calculate that further because that itself is given like an option C. See this, that's the answer for the problem. That's how we have to solve the problem. So lot of concepts are involved in solving this. I want you to re-look into the data once again, solve this problem once again, solve it on your own on a paper. Don't see this video and say that you have learned it. You have to derive yourself and learn it. While you are deriving, if you got any doubt, come back and see the video. If still there is some doubt, you can just make a comment there. That's it. Thank you for watching.